In today's video, let us learn about Vsepr theory. Vsepr refers to valence shell electron pair repulsion theory. So here we are going to consider the electrons present in the valence shell of an atom and how it is related to the structure of the molecule. Okay. Now, shapes and structures of the molecules could not be written using Lewis structure. Hence, Vsepr theory was put forward by Sidgwick and Powell in the year 1940. Vsepr theory successfully explains the structure of most of the covalent molecules. Now, what are the postulates of Vsepr theory? The shape of the molecule depends on the total number of pairs of electrons around the central atom of the molecule. The shape of the molecule, whether it is tetrahedral or it is linear, it depends on what? Total number of electron pairs around the central atom. Okay. The electron pairs will repel each other since they are negatively charged. Since they are electrons, they are negatively charged, therefore they should repel each other. That is our second postulate. Hence, because they repel each other, the electron pairs tend to occupy their positions in 3D space in such a way that they will experience minimum repulsion from each other. Electron pairs are present in the valence shell. Because they are negatively charged, they will repel each other. Because they will start repelling each other, they have to adjust themselves in 3D space in such a way, in such a manner that they should experience minimum repulsion. This positioning gives them maximum stability to the molecules. When the electron pairs are placed far away from each other, then the molecule will have maximum stability. There are two types of electron pairs around the central atom. So we are talking about electron pairs, and there are again two types of electron pairs around the central atom. So one is called as shared pair, the another one is called as unshared pair. What do you mean by shared pair? These are the pair of electrons which are involved in bonding, and unshared pair means they are the electrons which are not involved in bonding. Therefore, they are called as unshared pairs. So, shared pairs I am going to call them as bond pair, and unshared pair I am going to call them as lone pair. The bond pair is shared by two atoms. Lone pair is not shared. It belongs to a single atom. Now look here. I have a central metal atom A, and I have shown a pair of electrons, and this is not involved in bonding. Therefore, it is called as unshared pair or lone pair. And I have another metal here, another atom called as B. One electron is coming from B, another electron is coming from A, and they are sharing an electron pair, and this pair is called as bond pair. Bond pair electron pairs are involved in bonding. Lone pair electrons are not involved in bonding. According to Vsepr theory, the electron pairs repel each other and they follow the following order. There is maximum repulsion between lone pair compared to lone pair, and bond pair. So the order is repulsion between lone pair is greater than lone pair, bond pair, and repulsion between lone pair, bond pair is greater than bond pair. So maximum repulsion is seen between lone pair, and minimum repulsion is seen between bond pair. Based on the number of bond pairs and lone pairs present on the central atom, the molecule will have a specific shape. So based on how many lone pairs and bond pairs are present, the shape of the molecule can be determined. Example, suppose we have a compound of the type AB2. It means central atom is A and it is surrounded by two atoms. Suppose we have a compound of the type AB2 having only two bond pairs. Then according to Vsepr theory, the two bond pairs are arranged at an angle of 180 degrees to one another. The shape of the molecule will be linear. Now why they are arranged in this way? Because to avoid repulsion. They want to have minimum repulsion between them. Therefore, they get distributed like this, and the shape of the molecule will be linear with a bond angle of 180 degrees. What happens if it is lesser than 180 degrees? There will be repulsion. So, in this position, molecules of the type AB2 will have minimum repulsion and maximum stability. So, we will take up another example. In the molecule of the type AB3, it means A is surrounded by 3 atoms. Okay. In the type AB3, compound having only 3 bond pairs, then the bond pairs are arranged in such a way that the angle between them will be 120 degrees. Once again I shall read. In AB3 type of compound having only 3 bond pairs, then the bond pairs are arranged in such a way that the angle between them will be 120 degrees and the molecule will have trigonal shape. Now I have central atom A here surrounded by 3 bond pairs. What are bond pair? It is a pair of electrons involved in bonding. So I have 3 bond pairs and the angle between them is 120. Why it is 120? If it is less than 120, what will happen? There will be repulsion. Yes, therefore they are comfortable at this position, and when they are placed in this position, the molecule will have trigonal shape. Athwa we can call it as trigonal planar. So now we shall look into various types of molecules having bond pairs only. Before going for other examples, let us look into another type, AB3. It means A is surrounded by 3 atoms of B. Okay, if in AB3 type of molecule, it has 3 bond pairs and 1 lone pair, then there will be repulsion between lone pair and bond pair. As a result, the bond angle reduces. Suppose in this type of molecule, expected angle is 109 degrees 28 minutes, then the measured bond angle will be less than 109 degrees 28 minutes. Why? Because of lone pair bond pair repulsion, the bond angle will be less than 109 degrees 28 minutes if that was the measured angle. Hope you have understood why there is repulsion, because we know that lone pair bond pair repulsion is more. As a result, what will happen? It will push the bond pair at a further distance, and this bond angle of 109 degrees will be reduced to 108 degrees. We have just quoted this number here. Fine. Based on the above knowledge, let us predict the shape of the molecules under 2 categories. Shape of the molecules in which central atom has no lone pairs of electrons, and shape of the molecules in which center atom has both lone pair as well as bond pair of electrons. So based on that, we shall look into the structure of the molecules. Geometry of the molecules with central atom having no lone pairs. Okay. So molecular formula AB2 having 2 bond pairs. There aren't any lone pairs. We are talking only about bond pairs. So I have a molecule of the type AB2 having 2 bond pairs. So this is A surrounded by 2 B atoms and they are having bond pairs. Right? So bond pair 1, bond pair 2. So bond angle will be 180 degrees and the shape of the molecule will be linear. Example for these is BF2, BCl2 and HgCl2. These follow. What are the shapes of these molecules? They are of the type AB2 having only bond pairs. Therefore, structure is linear and bond angle is 180 degrees. We'll take up AB3. AB3 having 3 bond pairs. So, I have central atom here. 3 bond pairs, bond pair 1, bond pair 2, bond pair 3. I have joined these 3. So, I am getting a trigonal planar shape with an bond angle of 120 20 degrees. Okay, so when you join these points, you will get a triangle which can be placed on a plane of the paper. Hence, it is called as trigonal planar. So, which are the molecules which exhibit trigonal planar shape of and which are of the type AB3? They are BF3 and AlCl3. Okay, now I have another type of the type AB4. AB4 means one central atom surrounded by 4 surrounding atoms. And how many bond pairs are there here? 4. A bonding with 4 B atoms. So here I have shown A is bonded with 1, 2, 3 and 4. Right? They have to arrange themselves in such a way that they will have minimum repulsion. So when they have minimum repulsion, then this bond angle comes out to be 109 degrees 28 minutes. And when you join these points, you get a tetrahedral structure. Now, so if you have AB4, you will think of a square with A in the center. It cannot have that structure because it is not stable. It prefers to have this particular structure. It is tetrahedron. Okay, similar, very much similar to pyramid, I can say. So, which are the molecules which exhibit this structure? Methane, SiF4 and NH4 plus. What is the structure? Tetrahedral. And what is the bond angle? 109 degrees 28 minutes. Why 109 degrees 28 minutes only? Because of minimum repulsion and maximum stability. When molecules attains that particular structure, and when you go and check the angle, it will be 109 degrees 28 minutes. What happens if it is less or more than that? There will be repulsion again. So another type is AB5. It means what? To the atom A, 5 B molecules are attached. So how many bonds will be there? Bond pairs? 5. Done? Yes? So I have central atom A surrounded by how many? 5 atoms, right? 1, 2, 3, 4, 5, which are joined to the central atom A. So which are the examples showing this molecule? We have PF5, PCl5, SbCl5, AsF5, etc. You should be very familiar with phosphorus pentachloride. And what will be the structure of the molecule? It will be trigonal bipyramidal. So I will help you to understand this particular structure now. And what is this? This is a triangle, right? And this is the base of the triangle. Now suppose I have a point here at the top, right? So I am going to join these vertices to this particular point. So you are going to join 1 and 2 from here to this point and 3 from here. So point means the nib of the pen. So you are going to get a pyramid like this, right? It will be something like this. So when you join all the points, you get a pyramid having a triangle at the base. Hope you have understood. So I have a pyramid like this having triangle at the base. That is called as trigonal pyramid. Trigonal bipyramid means what? To the same pyramid, if you have another point at the base. If you have another point. Now this is the base of the pyramid. So one point I had taken here at the top, and then I had joined these ends 1, 2 and 3, right? Similarly, below this paper, below this triangle, I have another point, imagine, and I am going to join all these 3 vertices to that particular point. Therefore, I have 2 pyramids, one above this base and one below this base. Since it is trigonal, I am going to call it as trigonal bipyramidal. One pyramid is above the base and one pyramid is below the base. Now I shall draw the structure of it and try to explain. So it is of the type AB5. So I have A here, A, and 5 atoms are attached to it. Atom number 1, atom number 2, atom number 3. Hope you are imagining this, right? So I am going to join these points. That gives me our triangle which I had shown earlier. So this is the triangle what I have drawn here. Now above A, directly above A, there is another atom called as B, which I am going to show it in 2D. So it will be above A and another will be below A, right? Now you are going to join these vertices to this point B, 1, 2 and 3. So this is one pyramid above the plane of the triangle, and I am going to join the same B, these points with the B written below the triangle, 1, 2 and 3. So you have two pyramids above the triangle and below the triangle, therefore it is called as bipyramidal. Hope you have understood. For the molecule of the type AB6, AB6 means A is the central atom and 6 atoms are surrounding it, right? So what should be the structure we shall see. If you look at this, you will not understand. I shall just write and show it to you. So I have central atom A. Okay, so I have A here, A, and it is surrounded by how many atoms? 6. So 1, 2, 3, 4. Join them. 3 and 4, and these are joined to what? A. This is our bond. The first bond, second bond, third bond and fourth bond. But how many bonds are there? 6. So one B is lying above the plane of the paper, another B is lying below the plane of the paper. So I shall write one B here, another B here. Then join these points, 1, 2, 3, 4. Understood? So how many faces it has? So this is one face, this is another face, this is third face, and the fourth face is here. So it has 4 faces. Similarly, I have another point below. So altogether there should be 6 atoms. So 6th atom is here. Again one face is formed. This is first face. Then this is the second phase which is here on the other side. Then you have third phase, and the fourth phase. Understood? It is joined by first, second, third and fourth. So you have 4 phases. This is the fourth phase. So it is like a square. It is a square. 1, 2, 3 and 4. This is the central atom. Above you have one atom and below you have another atom. You are going to join the vertices. So above the plane you get one pyramid, and below the plane you get a pyramid. But what is the base of the pyramid? It is square. Therefore you can say square. How many pyramids are there? Above 1, below 1. So it is square bipyramidal. But here I have named it as octahedral. Why octahedral? Octa refers to 8. Right? Hedron means faces. The above pyramid has 4 faces. The below pyramid also has 4 faces. So altogether how many faces are there? 8 faces. Hence it is also called as octahedral or square bipyramidal. And square bipyramidal or octahedral is shown by AB6. And which are the molecules which show this type of structure? They are SF6 and TEF6. Hope you have understood. Now we saw the geometry of the molecules having only bond pairs. Now we shall look into the geometry of the molecules having both bond pairs as well as lone pairs. Now I have a molecule with the formula AB2. AB2 having 2 bond pairs and 1 lone pair. So it should have been linear. Earlier we had seen A, B1, B2, but here one lone pair is there. Because lone pair is there, there is repulsion between lone pair and bond pair, and the bond pair is pushed below, so bond angle decreases. Therefore, it will not have linear shape, but it will have a bent shape. And which molecules show this? SO2 and O3. So, AB2 with only bond pair, you have linear structure. AB2 with two bond pair and one lone pair, you have bent structure. So, I have AB2 with two lone pairs and two bond pairs. How will be the structure? It should have been linear, but there are two lone pairs. So, lone pair repulsion is maximum. They push each other far away from each other. They are placed, and again when they are placed far away, lone pair again repels bond pair, and therefore bond pair is pushed further down and the bond angle still decreases. So again, which structure it will have? It will have a sharp bend. Example, H2O. So in the molecule of the type AB2, you have three types. AB2 with two bond pairs, zero lone pair, you have linear. AB2 with two lone pairs, two bond pairs and one lone pair, you have bent structure. And AB2 with two lone pair and two bond pair, you have a sharp bent. Example is H2O. So we'll take up another example, AB3. AB3 having how many bond pairs? 3 bond pair. Trigonal planar, but it is also having what? One lone pair. Because of that, what will happen is there is repulsion between lone pair and bond pair. Instead of getting trigonal planar, you will get a trigonal pyramidal structure. Example for this is NH3. You need to remember the examples. Hope you have understood valence shell electron pair repulsion theory. If not, go through the video again. Thank you very much.